Hello everybody, today I'll be presenting my final project called Discovering Music Trends, a Data Visualization Study. This is for my Info 4709 Data Visualization and Communication class, which is a course taught by Dr. Lindsay Hong here at the University of North Texas. My project focuses on analyzing a dataset called Spotify Global Music Dataset, which contains information over tracks from 2009 through 2025. I will conduct exploratory data analysis and visualization. I chose this topic because I believe that music is one thing that everybody can agree that brings us together, and it's something that everybody is passionate about to some extent. By analyzing tracks, artists, and listener behavior, analysts and shareholders can benefit from the results and will therefore help them understand different patterns and dynamics in music, leading to making better recommendation system for users. The analysis will resolve 3 different hypotheses, but it will also reveal the changing music over time, which is shaped by user preferences and other factors such as artist metadata. The dataset was taken from Kaggle and was uploaded by user Warda Bilal, which was collected from Spotify's API. The CSV file that I'll be focusing on, like I said, contains music from top artists from 2009 through 2025. The file contains a variety of columns, which has about 9,000 distinct track values, and the attributes in the dataset include different popularity metrics that will help in answering the different hypotheses that I have. Here I'm going to talk about the data pre-processing steps. I use Python for everything except the visualization part, where I use Power BI. The first step is identifying any missing columns and exclude them from the analysis. There wasn't any major data loss, but I removed parts where popularity and follower values were missing. The second step is to standardize values such as dates. This project will also cover time-based analysis, so it's important to have a consistent format. In the second piece of code that you see, I created a column called release year and extracted the year value from the album release date. And then for the third step, I created a new column called primary genre using a Python function that extracts the first variable in the list of artist genres, so it'll be easier to visualize. My first hypothesis is that tracks with certain audio features or artist characteristics tend to receive a higher popularity score. In the next slides, I'll be talking about other extra steps taken to prepare the data and visualization alongside the results. On the top left here, you can see code that shows different correlation values. This is not that important to the analysis, but I wanted to get an idea of what the visualization will show. As you can see, correlation values such as the artist's popularity have a mildly positive relationship, and then the artist's followers does influence track popularity, but not as strongly. And you can also see that factors such as track duration does not really impact track popularity. For the visualization, I decided to create a simple scatter plot by using track popularity in the y-axis and artist popularity on the x-axis, and I colored it by the primary genre. And I also made it so you could filter by genre, so it could have an interactive feature. The scatter plot shows a moderate relationship between artists and track popularity, also showing an upward trend. This means that tracks made by more known artists achieve higher popularity scores. This supports the first hypothesis and shows that artists and song popularity are great predictors of track influence. Now we move on with the second hypothesis, where we see if listeners' preferences and pattern shifts have an influence on track popularity over time. These are the steps that I took to answer the second hypothesis. First, I decided to focus on the release year of songs. So I grouped the data by release year and calculated average track popularity for all songs from that given year. I then created a line chart again in Power BI by displaying a year on the x-axis and track popularity on the y-axis. And then these are the results of the visualization for hypothesis 2. As you can see, music from the 50s to 80s display a little bit more variation, where music released from the 90s onwards show that there is a little bit more of a consistent and stable pattern, with the average of popularity being around 50. This also supports our hypotheses and shows that the digital era now provides more uniform exposure across different artists and genres. This also shows that there are changes over time and that certain behaviors do evolve. Now we move on to the last hypothesis, where we are going to find out if different artists who have a higher influence, judging by metrics like followers and popularity, tend to have more popular tracks. Again, I will attach a piece of code that will help us understand how the data is behaving. I created code to show the top artists by average popularity, followers, and then the top genres by also by popularity. I then create a bar chart in Power BI that compares the artist's name versus a total number of times the track has been considered popular. And then here are the results. As you can see, there is a small number of artists that contribute a disproportionately large share of popular tracks. That also means that popularity is highly concentrated rather than it being evenly distributed, therefore supporting the alternative hypotheses. And here we go into discussion and future work. The results of the project show that there are several meaningful patterns in the Spotify dataset. Using the three hypotheses, we're able to show that there are characteristics that have an effect on whether a track is going to be popular or not. There are also several ways that we can improve this research and analysis, and it could be by implementing other features such as audio analysis features like tempo and energy of a song to have a more in-depth analysis and allowing a more direct evaluation rather than depending on basic metadata.